Hello students, welcome to the new session. In this session, we are going to discuss about the numerical problems based on spring mass system. So here we have some problems. Have a look at the problems. The first problem is here. A spring of force constant K is cut into two equal parts and a mass of M is suspended from the parallel combination of the springs. Then the frequency of oscillation is so see here, first we have a spring which is cut into two parts. When we are cut into two parts, the length is going to be L by 2. And the spring constant, actually before cutting the spring constant is K. After cutting the spring constant of each part is going to be, we know that, 2 times of that. 2 times. Each part is going to be 2 times. 2K and as well as 2K. Now, these two parts we are connected parallelly and suspended by a mass M. So this is 2K and this is also 2K. So now what happened to the time period and as well as frequency of oscillation? So see here, now this is which combination? Parallel combination. Parallel combination means the effective spring constant will be goes to K1 plus K2, 2K plus 2K, 4K. And frequency of simple harmonic motion is 2 pi into under root K by, time period is 2 pi into under root M by K, and frequency is going to be 1 by 2 pi into under root K effective upon M. What is the value of K effective? 4K. Then frequency is going to be 1 by 2 pi into under root 4K by M. So this is the answer of the question. And let's see the second question. What is the second question is here? A spring of natural length 80 centimeters, means without any extension, its length is 80 centimeters. With a load, it has 100 centimeters length. So natural length is 80 centimeters. If you are attaching a load, so the weight is going to be the extension is going to be 100 centimeters. Here only spring natural length 80 centimeters. If we are attaching some weight, that is going to be 100 centimeters. And if it is slightly pulled down and released, then its time period of oscillation. It is just slightly pulled down, and then released, and it is making the oscillations. Now we have to find the time period of the oscillation. We have to find the time period of the oscillation. To get the time period of the oscillations, first we need to know the value of the actual time period formula. 2 pi into under root M by K. But in that we don't know the value of K, and that we don't know the value of M also even. So then how do we can find that? Yes, there is another alternative. The another alternative is due to the weight, what is the extension? Extension due to the weight, we can able to take 20 centimeters. Yesterday we solved it. Whenever if a body is attached to that spring, due to its own weight, it can extend some length due to its own weight. So due to its length, how much? 20 centimeters. We know that weight mg is equal to, we can take kx, right? Yes. Now take m by k, which is equal to x by g. M by k is equal to x by g. Both m by k and as well as x by g. Now you know the value of x? Yes, 20 centimeter. You know the value of g? Yes, how much? G is equal to 9.8. You can take. Just put this value in this expression, then you are getting the answer. So the answer is T is equal to 2 pi into under root x 20 centimeters means 0.2 meters, or else you can write 20 centimeters only, no problem, upon pi value is actually, this is 9.8 if you are taking here, 9.8, and this you have to take in meters, 0.2 centimeters. 0.2 centimeters. So now this 9.8, root 9.8 means pi, and as well as root 9.8 will be cancelled. Then 2 into, so what is the root 0.2? Root 0.2. It is somewhat difficult. Actually, we felt like that, but it is easy only. So root 0.2 value 0.447. Root 0.2. Root 20. Root 20 how much? Root 16. 4. Root 20 how much? 4.47. So root 0.2 is 0.04. So if you are multiplying it, how much you can get? 0.89 seconds. How much? What is the time period? 0.89 seconds. Let's see one more problem we have here. So see, the problem is here. A spring block system of length is increased by 4%. Then what about the time? The spring mass system length is increased by 4%. Then what about the time period? Actually, they asked that. We know that. Actually, just now we wrote it. T is directly proportional to m by k, and m by k is equal to x by g. Right? M by k is equal to x by g according to this. That is nothing but, then T is directly proportional to x by g. Right now, T is directly proportional to x. Now length is increased by 4%. 4%. So then time period is going to be how much percent? 2% increase. Here length is increased by 4%. Under root 4 is going to be 2. So the time period is increased by 2%. 2%. So this is all. And one more problem we have here. So hope you understand the problems. So see here, easy and as well as interesting problems. Next problem is very interesting. The fourth problem. What is that? The mechanical energy of a spring mass system is 1 joule. The mechanical energy of spring mass system, which is 1 joule. When it is an amplitude of 0.1 meter and it has the maximum speed of 1 meter per second, then what is the force constant of this spring? What is the force constant of this spring? So actually here we have the spring. The spring of mechanical energy, the system is how much? This mechanical energy is combination of kinetic energy and potential energy. Combination of kinetic energy and potential energy. Combination of kinetic energy and potential energy. Now, which is having some amplitude of 0.1 meter and as well as maximum speed. We know that when which is making the oscillations about the mean position. So for example, if you are taking like this, so when which is at a mean position, that is having maximum velocity, right? When which is at mean position, that is having maximum velocity. When which is having maximum velocity, then what about its potential energy? Yes, obviously 0. When which is at extreme position, what is the velocity? 0. What about the amplitude? Maximum displacement is nothing but peace. The particle, the total energy at extreme position. Total energy at extreme position is equal to potential energy. And total energy at mean position is equal to kinetic energy. Right? The total kinetic energy at mean position is equal to total energy. And potential energy is equal to at extreme position. Total. So now if you want to find the value of K, so here actually you can observe that they are not giving the mass. Without mass you are not able to find kinetic energy. Actually no need of that. You can go directly here. The total mechanical energy is equal to at extreme position. It is in the form of, yes, it is in the form of potential energy. It is in the form of potential energy. Then mechanical energy 1 joule is equal to half into K value into amplitude 0.1 into 0.1 is 10 to the power of minus 2. If you are sending here, that is goes to 2 into 10 to the power of minus 2, that is going to be plus 2. Then finally, what is the spring constant value is 200 Newton